YouTube, we're going to take all of our knowledge in this video that we've been exploring with complex numbers and imaginary numbers and put it to use. That is, we're going to use it to actually do something that is, beneficial to us, to solve equations, that is quadratic equations. Okay, so what I've got here are just three very, very quick examples, but what we're going to do is going to solve each of these equations for x, where formerly we couldn't do it because we didn't get real number answers. But now we can do it because we were familiar with the imaginary number I. And we're also going to check all of our answers by plugging them back in. So we're going to start with a very trivial example. Right here I say x squared is equal to -9. And one thing I want to recognize is this. We're saying, hey, I took a number times itself and I got a negative result, which is not necessarily possible when you're talking about just real numbers. So we say, well, if x squared equals -9, in order to solve this, we've already got the squared thing by itself. Let's undo the square thing by taking the square root. Okay, so we say the square root of x squared is just x. Over here, what we want to do is recognize that we're getting the square root of -9. Formerly, we took a long route. We said, well, this is the same thing as -1 times 9. That's the same thing using our properties of radicals as the square root of -1 times the square root of 9. And that's the same thing as, well, the square root of 9 is plus or minus 3. And we say the square root of I, or square root of -1 is just I. So we get this. We'd say, well, this is the same thing as plus or minus 3i. The quick route to doing this would be, let's go ahead and take a look at this here. We'd say this is the same thing as you just write plus or minus I out front. And you rewrite the 9 in there as being a positive 9. We say, well, we know the square root of 9. We say x is equal to plus or minus 3 times that I we had in front right here. So part of this exercise was plugging it back in and checking our answers. So what we end up with is this. We say, well, our original equation was x squared equals -9. Let's take a look at this. We're plugging back in here. We're plugging in a plus or minus 3i. So a couple things I want to mention. First of all, it has a plus or a minus here. There are two answers to this equation. But when you square a positive, you get a positive answer. But also, if we were to square this as a negative, you'd still get a negative times a negative as a positive. So what we turn out here is this. We get, well, 3 squared, which is 9. And then I squared is I squared. And we're saying that this comes out to equal -9. But recall that I squared is the same thing as square root of -1 squared is -1. So instead of I squared here, we'll write -1. And so we get -9 equals -9. So basically, I squared, the thing that makes it so profound is the fact that you can square it and get a negative result. Cool dude. Okay, so hey, letter B, a little bit different. We're built in a few more steps here if I was asked to solve this equation. It's just as simple as, hey, let's get rid of this 3 first. We got to isolate the squared base. So we'd say subtract 3 from both sides. So the 3's are gone. We get 2x squared is equal to -13, take away 3 more is -16. So now we'll divide both sides by 2. So now we've isolated x squared. We say x squared is equal to -8. And so now, to undo the square root, the square will do a square root. So this implies that we have x equals the square root of -8. So in terms of simplifying this, it is simple. We say, well, this is the same thing as plus or minus I out front, and we'll make this a positive 8. Furthermore, recall that the square root of 8 is the same thing as the square root of 4 times 2. We know the square root of 4 is 2. So we could say this is the same thing as plus or minus. Now, we're taking a 2 out front, which means we're going to multiply it by whatever was already out front. And we had an I out front, so we say plus or minus 2i times radical 2 left on the inside. So just notice here, if this had just been no I, square root of 8, it would have been 2 radical 2. But since it was a -8, we just say it's 2i radical 2, and that's just that. So we do want to check this solution. So the original equation is this. We said 2 times x squared plus 3, this equals -13. So if I put our plus or minus here, plus or minus 2i radical 2 back in, let's square everything we have in the parentheses here, which gives us a positive output guaranteed, but we get 2 times, now 2 squared is 4. I squared is, well, I squared. And the square root of 2 squared gives us just that 2 that was on the inside of it. Plus 3 equals -13. Furthermore, we'd say, well, this is 2 times, well, 4 times I squared, that's 4 times -1, which is -4 times 2 is -13, okay? And we say, doing what's in here first, order of operations, we say this now becomes 2 times -8 plus 3 is -13. So we get negative 16 plus 3 is negative 13. And so finally we end up with negative 13 equals negative 13. So this is a solution. Both of these answers here are solutions. So in this last example, the only difference is the thing that's being squared here has a little bit more substance on the inside of it. But hey, the squared thing is already by itself. So if I said, hey, go solve this, it's equal to negative 7. What this means is we can go ahead and take the square root of both sides right now, and that's going to get rid of this squared that we had. So we end up with x minus 1 is equal to plus or minus the square root of negative 7. So now the important thing here is we had a negative in here. Let's rewrite it with a positive. X minus 1 equals plus or minus. We'll put our I out front, and we'll just make what's in here a positive 7. This is, the nice thing about this is the square root of 7 can't be reduced any further. So we'd say this is what we get on the right. We still need to add 1 to both sides. And the fact is that 1 over here, this is a real number and this is an imaginary number. Okay, so we get a complex result. We can't combine those. We say 1 plus or minus I radical 7. Okay, so this is what we end up with here. We have two answers. Just to make that clear, we have x equals 1 plus I radical 7, comma, 1 minus I radical 7 are the two responses. So plugging this back in here, I'll try to write a little bit smaller, but the original equation said x minus 1 quantity squared is equal to negative 7. And so we're actually plugging in for this x that was on the inside of this there, and we're plugging in 1 plus or minus I square root of 7. And so what I want us to recognize here is this, that these two ones here and here, positive 1 and negative 1, cancel out, and it simplifies down into this plus or minus I radical 7 being squared equals negative 7. So now squaring both of these, well, we say I squared is, well, that's just I squared. And if we took the square root of 7 and squared it, we would be left with just 7. So we're saying I squared times 7 equals negative 7. Well, this has to be true because recall that I squared is the same thing as negative 1. So now we're saying negative 1 times our positive 7 makes it a negative 7. And this comes out to be negative 7. So this is a solution. Cool. So, the thing to remember here is you're still going to solve equations the same way. It's just that if you take the square root of a negative, make what's in there in the radicand positive by putting an I out front first, and then reducing as you know how to do. Cheers.